So Shimano came out with their full power e-bike motor, the EP8 in 2000, and they made some updates to it, and then a significant one in 2022, and they called it the EP801 at that point. Here I have a Canyon Spectral On that has the EP8, and here I have a YT Decoy and it has the EP801. The difference they claimed, there were a lot of differences, but one of the differences they claimed was the EP8 has 500 watts of power and the EP801 has 600 watts of power, yet they both have the same torque. Okay, that's kind of confusing. Now, what does that really mean? Unless you were able to ride both bikes, and I have, and I posted a test comparing the two motors in a technical climbing situation. You can check it out there on my channel. But unless you were able to ride them side by side, I don't think you'd really be able to tell the difference. So I set up a motor testing lab, and you may have seen my test on the EP8 motor. If you're not, check it out. It's on my channel. It will help with this video. But today I'm going to compare the EP8 to the EP801 to really tell what is the difference. Is there a difference? Is there more power? Why do they say there's the same amount of torque? Let's get into that. Now, before I get into the test results, you can check out on YouTube some others that have tested these two motors together. I've, as I mentioned, tested them. Lone Wolf has tested them. The results are still somewhat confusing, even from what I put out. I'm not sure why the EP801 performed better in some situations than the EP8. Feels better, climbed better. Lone Wolf said it climbed better in high, steep climbs, but on sort of gradual climbs there was no difference. So what does this all mean? To make matters worse, there's some videos out there that'll say power doesn't matter, it's all about torque. Or torque doesn't matter, it's all about power. Well, as an engineer, this drives me crazy because one, there's not a lot of data supporting those statements when they're made. And two, it's really not accurate. I mean, power and torque both have some relevance here. And you can check out, I've got a series of videos that I did on this subject that describe what power means, what torque means, and why there's a difference, and what difference it'll make for you as a rider. So in this video, I've set up a real test between these two motors with a real rider using power meters to test the actual power output, the actual torque output, and the assistance level that each motor gives the rider at each level of RPM. So the test setup I've got is a smart train with a power meter on it that will test the total power output of the bike and the rider together. And then I've got power meters on the pedals to test the power output of the rider. Then you can calculate the power output of the motor. And I can also calculate torque. And then what I do is I subject the rider-bike combination to various levels of cadence, various levels of resistance, and we come up with the power and torque curve. And as you'll see, it's the curves that matter. It's not those maximum numbers that we all read in the advertisements. When I do these tests, then we can both learn sort of what the real numbers are. And you also learn, I do, when I'm doing these tests, some interesting things about the bikes and the motors and how they react to our input. You just really kind of understand when you're on the trail. You don't know why it's happening, but you can see it in the test results. You can feel it in the test. And I'll talk about that towards the end of the video after I go through the results. So let's look at the test results. I tested, as I mentioned, the EP8 on the Canyon Spectral On and the EP801 on the YT Decoy. What I do, and you can see it here on this graph, is I find a resistance that will both make sure I get the maximum RPM out of myself while I'm running the motor and also the maximum power output. So I've got to fiddle with that a little bit. And then I run the cadence up, and this is a graph of the cadence. And I just start at as low a cadence as I can and work it up to about as high as I can pedal. At some point, the motor gives up and I can't pedal it at that resistance any longer. And what's interesting, and I'll talk about this more as we go along here, is the low cadence is something that's really hard to maintain consistently because it is a really low cadence. I mean, you're barely pedaling at 30 RPM. So the results I show is from 40 RPM up. 30 is very inconsistent, and we never ride at that low of RPM. You're more like a jerky. It's more like a jerky action when you're at that low of an RPM. I'll then take the data and I'll zoom in on it, and this is one example of it, and I'll pick a segment of it that may be about 20 seconds long where I'm at a specific RPM, and then you can tell a lot of things from this data. It shows here, the line below is the power output of the rider, the line above is the power output of the rider and the motor together, and the difference is the power of the motor. This also, of course, shows the percent assistance that the motor is giving. The other thing that happens when I'm running the test is I'll start running it up in RPM. Eventually, as I'm putting power into the motor will stop giving out power, and we'll see that in the results. But the motor will start backing off on its power output because it's running out of torque, because torque will not be produced at very high levels when the cadence is high. So eventually, the motor just cannot help. And you can see that in the graph here. If you look closely, as you get high in RPM to the right of the graph, you'll see the bottom line goes up dramatically. That's the rider, while the top line just goes up at a constant level. So really, that's just the rider's additional power being added to the whole system. The motor has given up at that point. So this is a graph of the power output of the EP801 motor. It shows power on the left-hand side and cadence along the bottom. So as cadence goes up with this motor, the power goes up. This is all tested at boost level. So I'm getting the maximum power I can out of the motor with stock settings. We'll get into that in a minute. But this EP801 motor seems to peak at around 80 RPM. So when you're riding your bike, if you're about 80 RPM, you're getting the most out of that motor. You'll also notice that I never got 600 watts out of this motor. I was never able to get 600 watts out of this motor, no matter what kind of test I put it through. Max I saw was somewhere around 550. Reliably, probably around 530 is what we're most of the time getting if we're riding it into optimum RPM on boost setting. So let's compare that to the EP8. The EP8 does put out less power than the EP801. In fact, at its highest levels, about 20% less power. So as advertised, the EP801 does put out more power than the EP8. But neither of them put out the advertised power, according to my tests. Also notice on both of these graphs, the power goes up until about 80 RPM, then it starts dropping off. And it will drop off pretty quick. The EP801 and the EP8 act the same way because that's the way motors act. Torque goes down as RPM goes up. Eventually, there is very little torque left for the motor to produce power. And so the power starts to go down. So let's look at torque. This is a very interesting curve, and there's a lot of things we can learn from it. First of all, the maximum torque occurs at very low RPM, where most of us do not ride. So how important is that maximum torque number really? It's not very important. Where it is important is where it gets out to 70 or 80 RPM, where most of us are riding. And in this case, the EP801 puts out just under 70 Newton meters, not the 85 max that it's advertised to have. And they do put that number out there a lot, but you can see it doesn't mean a lot. It's what happens at that higher RPM that matters. It's a flat curve. Motors don't act that way. Motors, you can see in my earlier videos, motors just linearly go down as the cadence goes up. But that's not what's happening on this curve because the motor is controlling it. The motor is capable of putting out 85 Newton meters of torque. I did see that on the EP801 at a very low RPM. It probably is capable of putting out more than that, but they meter it down with the motor controller. And they do it in a way that keeps the torque pretty constant over the cadence of the motor. In this case, with the EP801, you can kind of say it's a 70 Newton meter motor because that's generally on the max setting boost where they run the torque. When you compare that to the EP8 motor, again, it's about 20% lower. So the EP8 motor, I never was able to get 85 Newton meters out of it, no matter how slow I pedaled. It probably is there somewhere, but I couldn't get it. It would have been just way too slow. Again, they control that torque output throughout the RPM range, and they control this one at about 60 Newton meters. So I would call this motor, the EP8, about a 60 Newton meter motor, because that's where we're using it most of the time, whereas the EP801 is about 70 Newton meters. Again, about 20% difference. The last item I'll mention is power multiplier. The power multiplier is really how much more power is the motor providing when the rider inputs a given amount of power. So if I'm putting in 100 watts, how much more power is the motor giving me? If it's giving me an additional 100 watts, that's a multiplier of 1. And that gets advertised a lot as well. And I think that Shimano advertises these motors both, if I'm not mistaken, at 4 times rider's input. And that's about what I see at very low cadence. That number goes down. And this is one of those numbers that is very dependent on how we program the motor. Now, most of us, I'm sure, me included, have been running these motors with the stock settings. But almost every motor manufacturer will provide you with an app that you can use on your phone to change the motor settings. And at one point, I didn't think that was a useful thing to do because I felt like they knew the motors better than I did. It turns out you really do want to make changes to those settings. And I'm going to cover that in a future video because, as I've said in one of my earlier videos, one thing the motor manufacturer does not know, and that is you. As a rider, how much power you're putting out and how you ride your bike is very different from rider to rider. And there are ways you can tune these motors to specifically match your type of riding and your power output. I'm going to cover that in a future video, so if you want to see that, hit that subscribe button, hit that like button, hit the reminder button, the bell, or whatever it's called to get notified when these videos come out, because I'll be putting more of them out. I'm really interested in making some changes to the settings. So let me summarize and then go through a couple more things I learned while doing these tests I think you'll find interesting. First of all, we know now from these tests, at least according to my test, these motors do not put out the advertised power output. So the EP801 and the EP8 do not put out 600 and 500 respectively. It's less than that, but they do put out different amounts of power, and the EP801 is about 20% more powerful and more torquey. The torque numbers are probably accurate, but as I've said earlier, those are not very important because they are at very low cadence where you really can't hardly ride your bike, especially in the case of the EP8. So what matters about torque is what it puts out at about 70 to 80 RPM where you ride your bike. Now, a couple of the things I learned about this while running the test, and some of this we kind of notice on the trail, but in particular, power output, it peaks at around, say, 70 to 80 RPM on these motors. Over that, power starts to drop off and the assistance level drops off. And that you can really feel doing a test. On the trail, it just probably feels like you're getting weak, but it's not you, it's the motor. And so if you find yourself going up a hill, not even close to the speed limiter on the e-bike, and you're putting out as much power as you can, and the RPM is getting up above 80 RPM, that's the time to upshift, to get your cadence down. It's counterintuitive. You wouldn't do that on a non-e-bike, but on an e-bike, getting the cadence down will give you more assistance from the motor. So always keep it in that optimum RPM. And speaking of RPM, the other thing I learned, really low RPM, when the torque is the highest in the motor, it's really hard to control the test. And it's also really hard to control the bike on the trail. And so you want, in that case, shift down so you can get the cadence up. Because these motors put out the most torque at that time. That's when they're going to push that bike and get that bike moving really quickly. And harder to control, but it's harder for the bike to really know what you want because your power input is inconsistent, and it's also hard for the motor to understand its RPM in that case. So things get a little bit twitchy, and you can feel it on the trail. You can definitely feel it in the test. Again, keep that RPM, 60, 50, maximum, minimum 50, maximum 90, better off kind of in between. The third thing that is really important, I haven't covered much of that in this test, but I've done some testing on it already, is that is very useful to have customized settings available to you on the software that is provided with these motors. I've never really adjusted that until now, but it really changes how these motors act. Motor manufacturers kind of design these motors for the average rider, but none of us are average riders. We're always got something a little bit different about us, the where we ride, how much distance we want out of the motor, how much power we put into the motor, how much power we like to ride with for ourselves, and how much power we like to get out of the bike. Those are all things you can adjust with the software. I'm going to go through that. I'm going to show you how you can adjust your motor to your riding style. We'll show some examples of that. I've already done with one motor, my TQ motor. I'm really happy with the way that's working out. It's going to be a little bit more difficult with the EP801s because they've got curves that you're dealing with in the input software. But we will go through that and see if we can get that motor set up just for you. Look forward to that. I'm looking forward to sharing that with you. Please hit subscribe and hit a reminder button so you get the notification when that video comes out. Check out some of my other videos on power and torque and the test on the EQ motor, TQ motor, and that EP8 motor that I tested prior to this. See you next time.